Well, good morning, everyone. Welcome to the C&E Sales Monthly Webinar Series. I'm Jeff Butler, the Technical Manager here at C&E. Today's webinar is titled Ethernet Connections with the Banner Safety Controller. Our presenter today is Steve Wright, C&E Sales Safety Specialist. Steve holds a Bachelor of Science in Electrical Engineering from Wright State University. He's a professional engineer here in the state of Ohio. He's a certified safety specialist and a TUV functional safety engineer. Steve's been with C&E for 8 years and has more than 30 years of manufacturing and engineering experience. If you have questions, you'll notice a toolbar over on the right-hand side of your screen. You can submit those questions in that toolbar. I'll be monitoring those throughout the presentation. If it's something that didn't be addressed to the whole audience, I'll respond back to you privately. If it's something that we would address to the whole audience, we'll save it to the end and let Steve address that. Please be sure to attend next month's webinar hosted by Jay Swank. Jay's one of our drives and motion specialists here at C&E Sales. His topic will be Siemens VFDs, what drive is right for you. So I'll now turn the presentation over to Steve.
Thanks, Jeff. Good morning, everybody. I was going to start this webinar off with just a little overview of what the Banner Safety Controller is. I'm going to assume for the purposes of this webinar that most of you are somewhat familiar with it and somewhat familiar with Ethernet communications, but you should be seeing a picture of an expandable version of the Banner Safety Controller. The controller comes in multiple formats. The space unit can either be an expandable unit or a fixed unit. This display is optionally available. You see here an expandable version, and I could have up to 8 additional input or output modules depending on the complexity and breadth of my application. They're just plugged together. And most importantly, what we're going to talk about here today is this base module can optionally have an Ethernet port. All right, I seem to be experiencing some. There we go. So I wanted to just this is sort of an overview of what that connection is. That Ethernet connection on a Banner Safety Controller is in one direction. It can send status information to an upstream controller, and it's only in that one direction, but this is not a fail-safe connection. This is merely for status and reporting. What we're going to talk about today is sort of summarized on this screen ahead of you, and everything I'm going to say today can be found in a Ethernet user's guide, which is available on the C&E website. Some of you may also have attempted Ethernet connections for the older Banner SC22-3, and there's a similar Ethernet user's guide for it also available on the website. There are slight detail differences between how these two connect, but these two documents are pretty descriptive of the process of putting things together. So in general terms, the steps to do is you configure the safety controller and its communications, and then we configure the PLC or the Ethernet host communications. What we're going to talk about here today is 2 of the 3 ways that the Banner Safety Controller can communicate. We're going to show a little bit how I connect to a RSLogix controller using implicit and explicit messages over the Ethernet IP, and then secondly, connection directly to a Siemens comfort panel via Modbus. There's a third way that the controller can communicate, the PCCC format. If you're connecting to SLC 500s, that's the format you'd use. I'm not going to discuss that here today. It's probably getting a little bit outdated, but there's information about that in those 2 users guides. So if that's how you need to communicate, go there for good reference. So the first step is to actually configure the safety controller. And if you've been online with the controller, you see these enabled buttons, the network settings buttons, and when you click that, you get this dialog box. And about all you have to do is configure the IP address. I've never changed any of these default settings you see additionally in the dialog box. But the one thing I do see a lot is people forget that you have to send it to the controller independent of the configuration. So you have to go online to the controller and actually send these network settings independent of the configuration you built. But that should cover you for the safety controller end. So I'm also going to assume for the purposes of this webinar that most people are familiar with RSLogix programming and communication. So the simplest way to get a banner safety controller into an RSLogix controller would be to install the EDS file. The EDS file for the controller is available on the Banner Engineering website, and using the tool we'll get it installed in your organizer in this format. You see there that little yellow icon. Then to configure the module, obviously we're going to give it an IP address that matches the one we assigned in the safety controller. But we need to go and change the module definition a little bit. From the Banner safety controller, there are 3 available input assemblies. You see them listed here: small, large, and the error log. So most commonly, people would use the small assembly, and those are numbered in the Banner safety controller. You see that below. We'll refer to those numbers a little later in the webinar. But the data format, just change that to integers, and it should hook up in this fashion here. You see there differing sizes, but most commonly we use the small assembly for our interface. So the second thing you need to make sure is that it's recommended by Banner that we change the RPI to at least 100 milliseconds, and unicast will save you a little traffic on the network. I just show you here, some people may have an older RSLogix where we have to connect the controller as a generic Ethernet module. And right now we're just going to change these input assembly parameters to the numbers 100, 101, or 102, and the sizes you saw there, 8, 104, and 50. And I showed the smallest one here. The Banner unit doesn't support output or configuration assemblies, but you'll need them to complete the Ethernet connection, and these default values will remain same for you. This is what input assembly 100 looks like. There are up to 64 virtual status outputs available from the controller, and what you see in these 8 integers is 4 integers for the on or off status of those virtual outputs, and then another 4 integers that'll describe the fault status of those 64 virtual outputs. And if you've looked into this in the Banner safety controller, on the industrial Ethernet tab, I can configure those 64. Right here I can assign these just as I would a status output in the program. What I've done is I've just auto-configured it, and by default this is the 15 that were created for the project I use for this demonstration. And you see there's a couple. I can change all these, but these are just the default ones. Over here on the right, what I've done in the input data for that thing is I've just aliased all those to show you really that, just to reinforce that connection. So these are all just aliases, just for a little display here. So you see that's how they all match up. Just to run through the other assemblies, this is the assembly 101, which you see starts off with 8 integers, the same as 100. They reserve a block, and then I don't show them all here, but there's also 64 more integers that give you the fault index for each virtual output. The fault index represents the identifier for the fault message. So I don't show them all here, but that's how you get up to actually 104 integers in Input Assembly 101. 102 is probably the second assembly that most people would use, which is the fault log. And what the controller will report to you is the 10 most recent faults. And for each fault, it reserves 15 integers, which gives you the timestamp, which is the number you'll see here is the time of the fault in seconds since the controller was started. You see the name of the device that's faulted. The code actually has two parts, a code and an advanced error code. If you look at these in the manual, you'll see a code will be, the index will be, say, like 2.14. The 2, the value to the left of the decimal point, the error code. 14, the value to the right, the advanced error code. And the error message index is actually that number altogether. In this example, that would be 214. So you see that as I say, it reserves 15 integers for each fault, and you can get to those by looking at the, as I say, the 10 most recent faults. So if I continue on to the RSLogix side, here I've created a explicit message to capture the fault log. So this setup you see in the red box is just the default by selecting that get attribute single. But the attribute here, this number 1, is going to get you to the most recently recorded fault. The next one would be attribute number 2. And what I've done, what you'll see here, is I've created an element. This is going to capture the first, this tag is going to capture the first fault. So I just made my little project to say I want to capture the 4 most recent faults. So you'll see each one of those tags is actually an array of 15 integers, and that'll capture all the fault information. Just a curious thing when I was setting this up is I had to enter this path manually. I could browse to the safety controller and pick it, but this communication wouldn't take until I actually entered the path manually. Maybe it's just me, but I point that out as that may happen every once in a while. So if we compare the fault log information you'd see if you were looking directly into the controller versus what you're going to see when you look at it in an RSLogix controller. We'll start here by, to view it on the safety controller, you go online, select the icon, read from the controller, and then view the fault log. So the fault log, I've just created a single fault here. This is how it appears on the controller end. You see this is actually the error code and the advanced error code, which is all together. Sources gate. This is, it converted those seconds into minutes and seconds. But this is how it appears in the RSLogix in that fault 1. The number of seconds. If you're going to get your calculators out, you probably see these don't match just because I created this slide at different times. It gives you the timestamp, gives you the number of digits for the source. But you see, the curious thing here is this ASCII string is backwards. But that's all it's doing. I get 12 bytes to record that name, and you see the error code 21, and the index is 201. In the index it represents each advanced code as a minimum of 2 digits. Yeah, there's only 2 digits. So it appears. This is how it's going to appear in your RSLogix data table. This is just one version of a rung I created to populate those messages. Just a little logic here to get it going. Just to slow down, just to eliminate a lot of the communication. I've got a little timer here running that toggles between each of the 4 fault messages I want to record. So you see it's standard stuff. I've created a little message instruction here. And I mean, if you can still read this, this is the other part of that rung where I'm taking those, I'm swapping those backward bytes of the source name into a different location. That's all this is doing here. So it's at this level, to create the messages this way, it's a little cumbersome. So another way that I'm going to show you here is how I connected the controller to a Siemens HMI via Modbus. And Modbus has its own register assignment that's different from the connection to the RSLogix, obviously. But it's very similar. It's going to create it's going to look a lot like the 101. You see I've got 8 integers for the tags and the faults, and then the fault index is in the next 64 integers. And you see there's down at the end, there's also some additional index information is available, the error codes, all that are available just in different places. And at the very end, you see it's actually I'm taking 398 integers. The numbers for the seconds and the mode, the name, the configuration, the CRC are all recorded at the end there. And this is how the configuration log looks in Safety Controller. So we can address all these places. So what I'll show you here is just a couple of screenshots of a couple of simple screens I built on the Siemens panel. Just a little one here. I'm just going to see status, all these guys, and faulted. Nobody's faulted at the moment. You see my 2-hand control is red because I haven't activated it, but that's it. Just a simple little list like you do here, like I've done here. I've created a little section of fault logs, which is that timestamp in seconds since the controller started. The name of the system, system lockout, I created a discrepancy, or I created a serious error here. I shorted a terminal. So this is the fault code. This is the name or the index that identifies this specific fault message associated with the system lockout. And you see, secondly, I just had this for my 2-hand buttons that I had there. I created a little discrepancy fault. That's a 2.2 is going to look like. So thirdly, I would guess more commonly we would build some text lists based on the faults to get more information out about it. So in this particular screen, it's not dynamic, but I would go to the screen previous, identify this fault number, enter it here, and I could report additional information, remedy steps, lots of little things you could do to help you fix that fault. So that's, in a nutshell, that's kind of my simple use of one of these for an HMI. That's that was a pretty short and quick overview of that Ethernet discussion. I wanted to show you this screen that shows the number of technical specialists we have here at C&E. If you're not familiar with C&E, these are the people that are there in addition to your sales rep or the customer service people you may talk to more often. I included it because 3 of the automation specialists, Brad Hart, Larry Ponziani, and Jeff Weaver, all helped me out in the preparation of this webinar. And it's just one of the features of C&E that we have these technical resources available to you, and we all sort of work together, hopefully, to give you better solutions. And good advice. Lastly, I want to remind you of some upcoming sessions we're having about the banner safety controller in the near future. This training is not entirely product specific, though it features the banner safety controller. We're going to have safety engineers from Banner Engineering come down and lead these, but I'll be at these sessions also, as will Heinz Knackstead, another one of our safety specialists. There's still time to register for these. I want to point out down here that the training alone is $50 per person, but each company for $150 can receive the training for one person plus one of these banner expandable safety controllers with the display and the Ethernet connection. So that's a real value, because the list price for those things is almost $900. So consider these three events that are coming up. You can register for these on the C&E website. That was kind of a short glance at the Ethernet connections, but I want to thank you guys for listening. If there's any questions, I'll remain on the line here for a while, and I hope you guys have a good day, and I hope you learned something. If you have any other questions, that's my email address, how to get a hold of me, and the 800 number, you can call me there also. So thanks for listening, guys, and I will see you next time.
Hey, Steve, thank you. I'm looking at the question panel right now, and I don't see any coming through. We'll give just a few minutes for attendees to type something up if they're in the process of doing that. And if we don't see something here in the next minute or so, we'll go ahead and end the webinar. Thank you. All right, Steve, I haven't seen anything come through, so I'm going to go ahead and stop the recording, and you can end the webinar if you like.
Thanks, Jeff.